All right, hello and very warm welcome to Azure DIY Week 5 of Season 2. My name is Imran Arshad and I will be assisting today with this session. So, So this session is actually part of the series that we are running since October, and I hope you're liking this series. We had a session last week about containers and how to run them on Azure App Services. That was a very wonderful session, and if you missed it, don't worry. You can always go back and check our LinkedIn page for the recording, and the link to this I will be sharing with you shortly. Today we have Chris Padgett from Arino, and he will be talking about infusing the intelligence into your application, and I hope you're going to love the session. Moving forward, so a few housekeeping points. Just to be reminding you again that this session will be available on the YouTube. So if you have any questions, please do not wait until the end of the session. You can just pop them into the Q&A section and we will be responding to them. So the link in front of you is actually our LinkedIn page. Feel free to go and join our community, which is growing pretty fast, and we will love to have your feedback on the session or what you would like in the upcoming session from us. Now, I'm going to move on to the exciting part, which is actually asking you a few questions. And so let's give your brains a bit of a work to do, and you would see a question on your screens. And here is the first question. So what is the name of the Azure service that actually can analyze the content in images and videos? 20 seconds. Any takers? To make it a bit of easy, I take away 2 of the options. It's easy.
Feel free to just click the Q&A button and enter in your responses in the Q&A live event section.
Thanks, Duncan. Do we have any answers yet?
Not yet. Anybody, any takers?
So we take 20 more seconds and then we move on.
Oh, we're at some. Azure Media Analyzer.
All right, so drum roll, and the answer is actually Azure Computer Vision. So this is our service that we can use to analyze the content within the image and videos. Let's move on to the next question. So Azure Translator is our AI service for the real-time text translation. How many languages do you think it supports? So please put in your answer in the Q&A section.
I've got a few more coming in.
And 5 seconds. No Googling, please. And the answer is 70 plus and growing. So you can use our Azure Translator service for the real-time text translation. Now, the next question is actually a really interesting question, and I'm actually loving it because we are also going to ask the same question to Azure Facial Recognition Service, and we'll see how closely you align with our Azure Facial Recognition Service answer. And the questions on your screen is how old Chris, who is our presenter today, and we ran the same question with Azure Facial Recognition Service. So put your guesses and answers in the Q&A section, and we'll see how closely you align with our Azure Facial Recognition Service. So 10, 15 seconds. I'm not sure you're going to like the answer, Chris, but we got what we got.
As long as it's not 100 plus. The others are.
All righty. 5 more seconds. You got anything, Duncan, there?
I put my vote in of 16, but.
Okay, so the answer is 36. And if you really want to try this demo or you like it, you can simply go onto the link, which is shared at the bottom of the screen, and just try some of your images and yeah, play with it. Now, before I hand over the session to Chris, just a bit of a reminder that the session will be available on our LinkedIn page at the end of this week. And if you have any questions, meanwhile, please put them into our Q&A section. So thank you very much, everyone. Enjoy your session, and over to you, Chris.
Thanks, Imran. I'll switch from your screen to my screen. Can you see the title slide?
Mm-hmm.
Perfect.
And you can see my browser if I switch to that.
Yep.
Perfect. Good afternoon, everyone, or good morning, everyone, wherever you might be located. I'm Chris Padgett. I'm a principal consultant at a Melbourne-based Microsoft partner, a professional services partner called Arino. Arino is only 18 months old, but we have a team of 20 Azure developers, application developers, IT pros, and 365 modern workplace consultants and specialists that work very closely with Microsoft on all things Azure and 365, whether that be related to development of applications, operations of infrastructure, management of identity and security, team deployments, so on and so forth. I'm pleased to be here today to present to you how you can build intelligent apps with Azure Cognitive Services. In terms of an agenda, I'll introduce you to the cognitive services and the range of APIs that are provided on the Microsoft platform for building intelligent applications. I'll demonstrate a Microsoft application called the Intelligent Kiosk to you to demonstrate examples of what you can build on top of the cognitive services platform services. I'll walk you through how you create a cognitive services API or APIs, what you're deploying, how they're deployed, and how you use them. I'll also demonstrate code examples of integrating with those and using those for scenarios such as computer vision, face detection recognition, and some other scenarios as well. Then I'll dive a bit deeper into what container support is available for cognitive services today, your development and deployment options and tools when using cognitive services in building business applications and managing the deployment of those business applications using DevOps tool chains. I'll talk to the security services that are offered and available for you to use to protect access to cognitive services, both at an authentication authorization level, but also at a network level. I'll then come up a level in terms of detail and catch a breath of air and talk about at a higher level an example architecture of an intelligent call center and how you can integrate cognitive services into a call center scenario to make that a little smarter and more intelligent for your business, and then leave you with a few resources that you can take away in terms of links to training, examples, quick starts, tutorials, as well as the Azure Cognitive Services documentation. So on to an introduction to cognitive services. So cognitive services are APIs that are built by Microsoft. They're managed by Microsoft and updated by Microsoft. They can be customized to a certain extent by you to allow you to add artificial intelligence to your business or consumer-facing applications. And you would do that in order to augment your end users' experiences, whether they're users inside or outside your organization, with some business machine-based intelligence to solve real-world scenarios, like we've done at Arino. Examples which might be biometric authentication, so facial or speech recognition during a login or registration process, the integration of knowledge or Q&A, FAQ style experiences into what are commonly called knowledge bots, where they be presented through a web channel to your external users or teams to your internal users. And also computer vision form recognition, text translation for digital document management and assets associated with those documents. These are just a few examples of solutions that we've implemented and deployed and created for clients of our business. In terms of the range of APIs that are provided by Microsoft to us as developers, and what can be customized by us, there's quite a broad range. I won't be providing examples or details, demos on every single one of these because I might need a few more sessions or a few more hours to do so. I'll focus on a few key ones during this particular session, but in terms of an overview of what is available and provided by Microsoft and what can be deployed and used by you, there are quite a few APIs kind of categorized into 5 key abilities or themes, if you will. There's the vision APIs, which covers everything from the analysis of content, detection of faces and objects within content such as images, recognition of text, recognition of layouts and structure and table data in forms, all the way through to analysis of audio and video, including the facial detection and speaker recognition in that audio and that video. So that kind of encompasses those vision APIs. We'll see examples of a few of these a bit later. The speech API, or the speech category, encompasses the speech service. This is a collection of speech services or speech-related services and APIs that assist with the batch and real-time speech-to-text, text-to-speech, speaker recognition, speech translation scenarios and services. So that's quite a comprehensive range of APIs that are available through speech. On to language. That includes language understanding, what you otherwise might know as LEWIS, which helps with the authoring and prediction of conversational text and natural language processing and understanding. Also includes Q&A Maker, which we'll see an example of a little bit later for authoring and querying knowledge bases and managing those knowledge bases and the FAQs associated with them, through to text analytics, which can be used for the analysis of sentiment and extraction of key phrases from text, and the recognition of entities, people, objects, things within that text, through to the translator service, which Imran mentioned a bit earlier, that allows you to translate text from more than 70 languages. The final category I'll just mention in passing here is decision making or decision. That incorporates some services that are kind of converged over time, and some of which are in preview, including anomaly detector, which supports the batch and real-time detection of anomalies in data over time, so time series data, detection of anomalies in that. That's also kind of growing or expanded into the Metrics Advisor API, which is currently in preview, which not only also assists with ingestion of that time series data into the Metrics Advisor service, the detection of anomalies in that data, and also the diagnosis of those anomalies over time, help with reporting and so on and so forth with that. The only other one I will mention here is Content Moderator. I'll provide a demonstration if we have a few minutes later in the remaining in the session a bit later. Content Moderator is a cognitive services API that assists with the analysis, classification, and review of content that might be considered offensive, risky, or undesirable, otherwise undesirable, in images, text, and videos, where that content may be provided by people outside your organisation or even inside it, and where you want to moderate that content before it's published and shared with others. So hopefully that gives you a bit of a feel for what's available through the Cognitive Services APIs today. Again, these are all built by Microsoft, they're managed by Microsoft and provided to us as developers to integrate with, some of which we can customize to suit our particular business needs or end user experiences. I'll move on to a quick demonstration of the Intelligent Kiosk. So this is an application that Microsoft has developed and published to the Microsoft Store. So you can get this for free for yourself. And to experiment with it. And Microsoft have also published the source code for it that's available in the Microsoft GitHub repo. I'll provide a link to this a little bit later for you to refer to in your own time. When you install and run the Intelligent Kiosks, you're offered or presented with a number of different demonstrations that you can use. In order to use these, you do have to create a cognitive service deployment for yourself, and then configure the keys for that service in the settings page here. I've already deployed that and set that up. I'll show you how to do that a little bit later. Onto a few of the demos, my favorite demos. So the first one I'm going to show you is the Vision API Explorer. So this is using one of the Vision APIs, computer vision, to extract or analyze, extract and present content, text, objects, faces that appear in images in this particular case. So I'm going to choose an image here of a man swimming. Now what's happening here is this particular image is being uploaded to my computer vision API that I've deployed, and we can see the results of the analysis of this particular image to the right-hand side here. So we not only see a caption or a description that's been returned from the computer vision API, a person swimming in a pool with a confidence score, but also analysis of the colors, the dominant colors in this image, tags that add metadata to the image, and we could store in our own content management system, for example, whether any faces have been detected, objects have been detected, text has been recognized. For faces that have been detected, we can see here it's a male of 33 years of age. And for any objects that have been detected, such as a person in this particular case, the confidence level associated with that as well. What this could also detect in this particular image, but wasn't detected in this particular example, was any brands that are represented, and if there are faces where any of those match a common or well-known celebrity. Also in this particular image, no text was extracted. So I hope that gives you a good example of what can be done with the computer vision API. I might just choose this second image here as well, which is an interesting image because it's blurred, because there's fast-moving or moving objects within it, including a fast-moving train and maybe some slow-moving or fast-moving passengers. If we check the summary, again, this has been uploaded to my computer vision API. Again, we have a caption for it, so it's detected that people are walking on a subway platform. There's a train in this image, as well as some people. There are no faces because they're all facing the other way, but it has detected two people, the man to the right and the child to the left, as well as the subway train moving past them. What's also interesting is it's been able to detect the time to the arrival time of the next train. It appears to be 3 minutes, as well as interestingly a pattern on the platform, which I believe is text, but there'll be a confidence score associated with that, which would be rather low. So that's the Vision API. I'll demonstrate, we'll walk you through a code example of how to use that a little bit later. The next one I'd like to show you is the Face API. So the Face API allows us to upload images of people, of faces, and the Face API will analyze and detect the attributes of the faces in those images, and in particular cases, recognize whether one face in one image is the same or similar to a face in another image, if we're trying to match people across different content. So I've just selected this woman's picture that's been uploaded to the Face API that I've deployed. It's detected that she's female, of 25 years of age, her hair color, whether there's any facial hair, whether she's wearing glasses, makeup, and so on and so forth. It also provides analysis of her detected emotion. In this particular case, she's got a happy smile on her face. pose in terms of her head tilt and so on, and the quality of the image that was analysed. Okay. Now that will work for both a single face, but also multiple faces in the same image. So in this particular case, I've uploaded this this new image. The face API that I've deployed has detected 3 faces, 2 of which are in focus and 1 of which is out of focus, but it's detected the out of focus face nonetheless, and provided an analysis of that particular face that's been detected. So yeah, that works for both people, single person in images, but also multiple people as well. The next one I'd like to show is the form recognizer. Just ignore this error message. The form recognizer is a more recent API that's been added to the cognitive services set that allows us to analyze a layout, structured data and tabular data in documents such as forms. And what we're going to demonstrate here is 2 kinds of forms, the first one being an invoice. Okay, so I've selected the invoice documents, a PDF file. This has been uploaded to the Forms Recognizer API that I've deployed for myself. And as a result, the Form Recognizer has recognized this particular structured content or table content in this PDF document. It includes the address in the top left, the customer in the top right, and also the invoice line items. Okay, you can see down here that's also been rendered in a table representation for my own presentation. So that's an example of an invoice. Now, in the example of an invoice, the Form Recognizer API would have to been trained on invoices like this in order to recognize the layout, structure, and the table data within them. But Form Recognizer API also provides built-in or pre-built models for documents such as a business card and receipts. So here's an example of a receipt. This is using a pre-built model, as I mentioned, rather than one that I've had it's had to be trained on by myself. And as you can see here, by uploading this receipt image or document, it's been able to, the pre-built model has been able to detect the merchant, Contoso in this particular case, the address of the merchant and their phone number, the date of the receipt, and also the line items on that receipt, a cappuccino and bacon and eggs for breakfast, presumably. Not only some of the printed text in the total lines there, on subtotal lines, but also some of the handwritten text that obviously the customer has added to the receipt before it's been processed. So that's a couple of examples of the Form Recognizer API using both a pre-built model for receipts, but also a custom model that was created for invoices. I now want to bring those 2 ideas of custom or computer vision and form recognition together into kind of a business example, an insurance claim in this particular case, and include automation for insurance claims. The idea here, the general idea here, is that an insurance customer can log into an insurance portal to upload a photograph of a cracked windshield in this particular case, as well as the invoice for the repair of that cracked windshield. Both of those items, the image and the invoice, can be submitted by the end customer through this customer portal. Both are uploaded to Cognitive Services APIs, one being computer or custom vision, the other one being the Form Recognizer. You can see here the results of that, the analysis of the image and the form. Computer vision or custom vision has recognized a windshield crack in the image, and also recognized the claim details in the invoice that was uploaded, including the customer's name. The customer's name, the date of the invoice, and some other information, including the invoice total. That, of course, could feed into an insurance claims processing process. Before I move on back to a few slides, just a couple of other quick demonstrations. I'll show you this speech-to-text explorer. I've connected this to a speech service that I've deployed for myself, and I'm going to demonstrate the real-time speech-to-text translation that's supported by that speech service. So if I start recording, hi everyone, this is Chris. I'm talking about Azure Cognitive Services. I hope everyone's enjoying the talk so far. That appears to be an accurate recognition or representation of what I've just said. And that is, obviously that's been translated from speech to text in real time. So that's an example of where a Windows desktop application like this is streaming audio as I speak to the speech service for the speech service to translate that to text and return that in real time. Quite a number of languages are supported here by default. More languages are being added. The next one I'll show you before I move on is the Text Analytics Explorer. So Text Analytics APIs is one of the language cognitive services APIs. What it's showing, I'm demonstrating here is the text of a document, a paragraph from a document, for example. That has been, if I click this Analyze button, that's been uploaded to the Text Analytics API, which analyzes the text, it texts the language, extracts any key phrases, terms and so on, as well as analyzes the sentiment of the document text that has been uploaded. So as you can see, it's obviously some text about a restaurant. Key phrases have been extracted from there, and they could be the names of people, the names of locations or objects. And we can see the sentiment is mixed, but mostly positive, in fact, highly positive. Okay. There's also a list of entities that have been recognized and represent names of, as I mentioned, people or places or things, as well as links to entities that exist in this particular case on Wikipedia. So each of these entities have been recognized and extracted from this document text, and we're provided to links to where they may be defined or information may be available about them on Wikipedia or elsewhere. So that's what I wanted to show there. Hopefully that gives you a good feel for what can be done with Cognitive Services APIs. Return to my slides. So how do you create these Cognitive Services APIs for yourself? We can deploy them using the Azure portal, the command line tools, or Azure Resource Manager templates, or the Azure SDK. In terms of using the Azure portal, which I'll show in a moment, you can deploy what is known as an all-in-one resource. I mentioned that in that second point there. So whether you're deploying using the portal, the CLI, or the SDK, for example, you can deploy a single Cognitive Services API, maybe the computer vision one, or the speech one, or the text analytics one, as a single resource that you manage as such. Or you can deploy an all-in-one resource that encompasses or includes most, not all, but most of the Cognitive Services APIs. There are some Cognitive Services APIs such as Custom Vision, Q&A Maker, that can only be deployed as a single service resource. Whether you deploy a single service resource or a multi-service one, all resources are protected using TLS and an authentication key or token. That authentication key or token can be provided by an Azure AD integration, either or an API key that's published through the Azure portal for you to use, or you can exchange that API key for an API token. That's the API key is obviously a long life key. The API token is the short-lived token that can be exchanged from that API key. By default, the HTTPS endpoint that's available for your Cognitive Services API is public, but I have added an asterisk there because that can be protected using network level controls and Azure virtual networks and subnets. But regardless, that API key is yours to use and protect, much like you would your other keys and credentials. In terms of what you're deploying and where, if you're deploying the Bing or Translator Cognitive Services APIs, and they're global, they are deployed as global resources, so they're not bound to a particular region. All the other Cognitive Services APIs are regional, so you effectively, when you create them, you choose a region in which to deploy them. But you also have the option of deploying some, not all, but some of the Cognitive Services APIs as containers into your own data center. That data center could be Azure container instance, it could be an AKS cluster, it could be a different cloud provider, it could be your own data center. So you have a few options there in terms of choice of where those some of those Cognitive Services APIs that are available as containers can be deployed to. Just to quickly show you how to create one of these using the Azure portal. I've signed into my Azure subscription. I've already deployed a few Cognitive Services APIs to support my demonstrations. Go and add a new one. If I want to deploy an all-in-one, I choose Azure Cognitive Services, click Create, choose the region in which I want to deploy them, the Cognitive Services APIs, give it a name, choose a tier, accept the T's and C's and review and then create that. A few minutes later, they'll be available to use. That's an example of deploying an all-in-one cognitive service. If I want to deploy a specific one, such as computer vision, I choose it and just follow the prompts. Choose my region in which to deploy it to, give it a name, and choose a pricing tier. I can review and create that. Switch back to this. So having created my Cognitive Services APIs, in terms of how I'd use them, at least at an API level, we'll walk through a bit of code for this in a few moments. In terms of the API contract or interface or specification, all APIs, or at least for all Azure Cognitive Services APIs that were created recently, such as the ones I've created for this particular session, include a custom subdomain. So when I in Azure portal create an all-in-one cognitive service, I have to specify a name for that service. That name becomes the custom subdomain that is associated with that particular deployment of my Cognitive Services APIs. So it not only includes a custom domain, but all APIs that I can use in that Cognitive Services deployment has a part of the path, the version for that API, and the operation I want to use forms the full path of that API. Because all these APIs are protected using an authentication key or token, an API key or token that must be passed as a request header. All requests are formatted as JSON, and all responses are formatted as JSON as well. All the different APIs have different response codes. It's also important and they're fully documented by Microsoft in the corresponding documentation for each API. It's important to also understand that most of the APIs or the API responses are synchronous. So you request an operation and wait for it to complete. However, some of the API responses or the API operations are asynchronous. So you request for it to start, you poll an operation endpoint to check on the completion status of that particular operation before the final response is returned to your application code containing the results of that particular operation. So again, that's well documented in the Cognitive Services API documentation on the different types of operations and responses that you can expect to receive. Let me switch to a bit of code for a few minutes. Open up Visual Studio. So I have a few demonstrations or quick starts basically here that I can show to you. I won't show all of them in the interest of time, but I will begin with the computer vision one. I'll walk you through what this will do just after I run it for the first time. So what this is going to do is, I'll just open up a few images. It's going to, it's a console application that's integrated with the computer vision API that I've deployed for myself. So I configured it with the API endpoint and key so that I can upload this particular image to begin with for it to analyze the features of this, or the attributes, the features, the objects of this particular image. Obviously, a dog with a collar. Let's see how it goes. I'm going to run this. Okay, bring this up here. Maybe just increase the font size so that we can read it. Just bear with me for a moment. Okay, so when this ran, it uploaded the dog image, sample16.png, and within a few moments, it returned its analysis of that particular image, the type of image, and whether it's clip art or as a line drawing, the color scheme. You know, these are a few of the attributes that we saw in the Intelligent Kiosk demonstration when the man was swimming. It's returned a caption or a description with a confidence score of what it believes the content of the picture to be: a small dog with a bow tie. Just close, not close enough, but it's a good stab. Categories or tags and tags for content of the image, objects, and so on and so forth, each with a confidence score. Whether the image contains any adult or racy content, and a confidence score for each of those. And like we saw earlier in the Intelligent Kiosk demonstration, were there any brands, celebrities, faces, landmarks, and objects within that image content as well. So that I'll show you how I interact with the computer vision API in a few moments to send that request and process that response, but you can see that's the result of that there. The next one I want to show you with computer vision is this image, analysis of this image and the detection of objects within this image. So this is the same API, but a different operation. The first operation for the dog image was to analyze the content of the image. This one is similar, but different. This is going to detect objects with the image and just return information about the objects that it has detected in it. So I'm going to press continue to do that. So it's uploaded the sample 9 image and it's detected there are 2 objects within it, a skateboard and a person, presumably on that skateboard, each with coordinates about where it detected those objects in that image. You might remember in the Intelligent Kiosk demonstration when I listed the objects for the man that was swimming in the pool. And one of the objects it detected was a man, and when I hovered over that detected object, it could frame it in the image based on the coordinates and the location of that object within that image. The next one I'm going to show you is analysis of this image by a built-in domain, in this case landmarks. So I'm going to upload this particular image, and I wanted it to detect, computer vision API to detect what landmark this is. So I'm going to press enter, upload the image, landmark.jpg, and it's determined that this is the Colosseum with a high degree of confidence, which appears to be correct, which is good. The last one I want to show you in this computer vision API is this image here, obviously containing text. I'm going to ask the computer vision API to read this image text and return what it has recognized. So again, I'm going to continue. So I'm uploading the image 3.png, and this is what it's read. Now, what I've not shown in here is the coordinates where it's read from, just to keep this a little less than verbose. But you can see here that what it's read, give or take a few characters, is close to what the text is in the image itself. I think it's missed a few characters because, in fact, that text has been clipped. So that's a good result. Just to show you how that's, I pulled that together in terms of this console application. So here's my main line here. I begin by creating a computer vision client object with the endpoint for my deployed API and the key and the API key for it. And then I call a method. I basically have a method for each of the demonstrations I showed you. One to analyze an image, another one to detect objects, and so on and so forth. Let's just have a quick look at how I use the analyze image operation of the computer vision API. I provide to it, or pass to it, the computer vision client that I've created and the URL of the image to be analyzed. Now, before I call the analyze image operation on the computer vision client, I want to which I'll pass the image URL. I also pass a collection of features or a list of features that I would like to analyze or detect in this particular image. You can see a full list of those features here. Okay. So with the image URL and that list of features, I call the computer vision client and execute the analyze image operation and wait for it to complete. And then, as we saw in the console output, basically just iterate over the properties of and present the properties of the result object that's returned from that API operation, including information about the image type, the color scheme, the caption that has been, returned for that particular image, categories, tags, any adult content, brands, so on and so forth. So it's a simple API to use, certainly in terms of the REST interface and also the SDK or the client library that's provided for not only .NET but a number of runtime platforms as well. The other one I'd like to show you is Q&A Maker. So Q&A Maker, like I mentioned a little bit earlier, provides the ability for you to create knowledge bases, add questions and answers to those knowledge bases, and to manage adding or removing those questions and answers over time. Whether those question answers are ones that you kind of predict a user will ask and you provide an inline, you will kind of want to manage it as a basic Q&A, or whether in fact you have external Q&A that you manage on a website or a SharePoint site or whatever the case may be, using that as your knowledge base content. So what I'm going to show you is using this example, Q&A about Q&A Maker basically. I'm going to upload or refer to this particular URL, upload the content of this page, upload the content of this page to Q&A Maker. It's going to train itself basically on the content of this FAQ page, and that as a result will form the content of my knowledge base that I'll ask a question of in a few moments. Now, in order to enable this, what I've done is in my Azure subscription, I've created an Azure Q&A Maker resource. To do so, I just had to add Q&A Maker, choose it from here, and continue through, name it, name a few resources associated with it, as well as a pricing tier for each of those resources. As a result, I have a Q&A Maker endpoint and an API key that I can use. In my demo, much like I did earlier, I configure that endpoint and key, create what's known as an authoring client in order to create a knowledge base of a given name. I can then programmatically download the contents of that knowledge base, update it over time to add more Q&A, remove less Q&A, so on and so forth. but ultimately publish that knowledge base for users, both inside and outside my organization, to interact with. Just to give you an idea of how I can create a knowledge base. So I have my Q&A Maker client that I've instantiated with my endpoint and key. I can, as I mentioned earlier, just add Q&A, questions that users might ask and answers that should be returned, as well as a bit of metadata or tags about that particular question and answer. So that's really just a Q&A 1, Q&A 2 that I add as a list of Q&A to my knowledge base that I want to create in Q&A Maker. But what I can also do is to create a knowledge base. I can also update that knowledge base by adding more questions and answers. Yep, including what is known as chit chat, just hello, goodbye kind of questions and answers for those inquiries from the end user, but also provide a URL or list of URLs, such as the URL for this troubleshooting FAQ page for Q&A Maker to read and then build a knowledge base from as well. Okay, I'm going to run that and show you the results of it. Okay, so I'm running that. It's creating the knowledge base in Q&A Maker with the basic Q&A to begin with. That's been done. I'm just downloading that to demonstrate that it now has 2 Q&As. I'm now going to update that new knowledge base with additional questions and answers, but also a reference to the FAQ page URL for that that I showed you earlier. That's been done. And to make this available to end users to test with or interact with, I'm going to publish that knowledge base. Now, to demonstrate that, I'm going to switch to the Q&A Maker portal. So I can log into this by going to qnamaker.ai. If I refresh this page, it will get the latest list of my knowledge bases. Okay, this is the one that was created just a few minutes ago. I can open it. You can see here it's got the chit chat Q&A for hello and goodbye. These 2 questions and answers for them were the ones I created or added when I created the knowledge base for the first time. So they're kind of just kind of inline questions and answers. And then you can see here that it's used this URL as a source for all these Q&A. This URL is, or this Q&A has been referenced, trained on this FAQ page here. Now what this all, and you can see here, the content for the answers doesn't just have to be text, it can be richer content like images like this. What this allows me to do is test that using this experience over here. So I'm going to begin the testing my knowledge base by saying hi. The response to that is hello, but also a choice that I can make. Maybe I want to learn more about the REST API support for cognitive services or knowledge bases. So and that includes the answer to that includes a link to the documentation for that. I can ask a question like, where is my Q&A Maker endpoint? Okay, now I've asked that question, which is not exactly the question text that was expected, but it's close. And so that's the power of Q&A Maker. It's using some other cognitive services to understand what I'm asking in the language that I'm asking it and matching it against the question. It doesn't have to be the exact an exact match. And as you can see here, this is the answer that's been returned to me. Okay, so hopefully it gives you an idea of how you can create, manage, and integrate with Q&A Maker programmatically, but also the kind of experience you can provide to your end users as a result. Onto a few more slides to begin to wrap things up. So I mentioned support for containers a little bit earlier. So Azure Cognitive Services support containers for deployment on a container platform such as ACI, AKS, or your own premises. And the key reasons why you might want to consider these are for compliance reasons, where you want to keep the data close to the service that is using that data, and where you may have requirements for that data to be not in Azure, for example, or not managed by Microsoft. So in this particular case, you can deploy a cognitive service container for the API that you containers are supported for compliance needs, maybe for higher security or higher throughput. What I didn't mention earlier is all these cognitive services APIs, depending on the pricing tier that I choose to deploy them on, have limits, quotas. So if you have a technical requirement where you will, and those quotas will will be limits on your usage of them, then you can deploy the container service or the container image for that cognitive service API into your own infrastructure to provide that higher throughput if that's what you're after. Containers aren't provided for all cognitive services today. These are the ones that they are provided for. They're provided through a number of, I guess, either as generally available containers, available in the Microsoft Container Registry, as well as the Docker Hub one. Some containers are provided as an ungated preview. What that means is they're offered as a preview container for you to use without any approval. But also other containers, I guess, are more in a kind of a private preview state, kind of considered to be gated previews. That means you can request access to them. That access will have to be approved by Microsoft before you can deploy or use those container images. So that's just something to be aware of. So further support for containers for more APIs is being added, and it is growing and increasing. So just be aware that those container images are made available through different preview and public options. In terms of developing against cognitive services and the APIs are offered, there's a number of different, I guess, options and platforms and tools that you may consider building your intelligent application on and integrating with these cognitive services. Yes, for the business developer or the business user, they can use the Power Platform, in particular API Builder and Power Automate features or services on Power Platform that are pre-integrated with a few of the cognitive services to make that the business user an easy way, a low code or no code way for them to build intelligent applications for their business use. They don't need a lot of development experience to do so. For the data engineers amongst us, and I'm not one of them, by the way, Azure Databricks and Azure Synapse Analytics has integrations with some of the cognitive services as part of their data pipelines. So it might be worth checking out if you're a data engineer. If you're a developer like myself, then Azure Functions and Logic Apps are good candidates for integrating with cognitive services based on triggers of events in applications, or maybe even integrating with cognitive services as part of the business process that you're implementing or supporting with an Azure Logic App. If you're into DevOps, there's a couple of links here that I can refer you to give you a few ideas on how you might implement continuous integration and deployment for intelligent applications, in particular the kind that I guess the code or the configuration, the setups that's required to manage a cognitive service API over time as the functionality of that service changes based on your needs. I'll dive into a little bit of that in the next slide. In terms of integrating your applications with these cognitive services APIs, you can use the REST APIs, of course, but Microsoft also offer a number of SDKs for each of these services that are provided by cognitive services across multiple platforms, whether they be .NET, Java, JavaScript, so on and so forth. Finally, and I demonstrated one of these earlier. So some of these cognitive services offer their own portals and tool sets as well. Q&A Maker is one of those. Examples of some other cognitive services that have their own portals and tool sets include Custom Vision, Language Understanding or LUIS, and the speech service as well. I guess the gist here is that whether you're a no-code developer or a high-code developer, there's quite a few options for you to build intelligent applications and integrate them into the cognitive services and manage those integrations using the CI/CD tools that we're using today. Just quickly on that, here's an example of a CI/CD workflow, if you will, for language understanding or LUIS. LUIS has a number of different tools that are available by Microsoft and others to support CI/CD or the CI/CD workflow. Whatever kind of branching or merging strategy you may choose to use or are using today. Basically, in terms of CI, when deploying a LUIS application, you can deploy a LUIS application, which is really, I guess, really the container for the language or the content that you expect your users to be using, or the language they'll be using, and you want to understand. And so you can build an intelligent experience from that, like I showed you with Q&A Maker. You can create a LUIS app using a source file known as LU or LU down. That basically contains the language that you want LUIS to understand for you. You can then update and train and publish your LUIS application using the LUIS CLI tool that's made available by Microsoft. You can then test what you've published to LUIS using another Microsoft provided tool called Natural Language Understanding.devops. And then once that's all done as part of a kind of a CI build and test, if you will, you can then delete that LUIS application. This is kind of analogous to kind of deploying a test database, running a set of tests against it, and then deleting that test database. Same sort of idea with a LUIS application. Of course, you don't want to be creating new applications or certainly deleting them into production. So as part of the continuous delivery or deployment, it's pretty much the same as what's on the left here, except rather than creating a new LUIS application in production, for example, you create a new version of for that application and then update, train, and publish to it. And obviously, you don't delete it. But you'll be using the same tools as part of your CI workflow for your CD workflow to achieve the outcomes that you need from a DevOps point of view. So hopefully this is not so a one size fits all or a kind of a recommendation one way or another, but hopefully a few ideas on what you can do with CI/CD and cognitive services. Just very quickly before we begin to wrap up, the presentation slides. In terms of how you secure your cognitive services, this can be managed at a number of levels, both at with authentication using a few of the methods I mentioned earlier, Azure AD, an API key or an API token that's exchanged for that API key. If you're using Azure AD, then your cognitive service, firstly, must be deployed using a custom subdomain. So if you've deployed a cognitive service API a little while ago, it may not have a custom subdomain. It will have a regional subdomain. You can add a custom subdomain to that cognitive service deployment to enable authentication via Azure AD. Azure AD authentication is available for some, not all of the cognitive services, but certainly many of the main ones and some of the ones I've demonstrated today. That Azure AD authentication not only supports user authentication, but also service authentication, whether it be via a service principal or a managed identity. So that allows an application, a function app, for example, to be deployed into Azure App Services, and the function app could access your cognitive services service as itself, rather than in the context of an end user necessarily. Authorization for cognitive services is managed using Azure RBAC, whether it be around authoring roles for Q&A maker, for example, or some of the other contributor roles that to manage the resources themselves associated with those cognitive services. Encryption is important for many clients that we've worked with. By default, all data that's managed in a cognitive service, if it's managed at all, has to be managed at all rather, is encrypted by a Microsoft managed key. Some, but not all of the cognitive services also allow customers to bring their own encryption keys and have that data encrypted using their own keys rather than the ones provided by Microsoft. Again, furthermore, the data that is managed by those cognitive services, or a subset of them, are also enabled for a feature, a little known feature, called customer lockbox. And what this allows or supports is the ability for you to lock access to the data that's been managed in your Azure Cognitive Service deployments. Basically lock it until you approve an access request by a Microsoft engineer to that data as part of maybe a support triage or process. Today, that customer lockbox feature is available for the Translator API, as well as these additional cognitive services APIs if you upgrade them to a particular tier known as E0. But that does effectively restrict access to the data that's managed in your cognitive services from access by Microsoft until you approve that access as part of a support process. Finally, like I mentioned earlier, by default, when you deploy a cognitive service API, it's public, it's internet facing, but there are options to add or connect your cognitive service APIs or deployments to a virtual network or a subnet in a virtual network that you're managing for yourself. In terms of those networking options, protection options, you can use service endpoints, private endpoints using private link, and also IP access or allow listing, whitelisting, in order to control the traffic flow in and out of your cognitive service deployments. I mentioned at the beginning, I just wanted to bring it up a level towards the end here and maybe get you thinking about how you might be able to begin to use and integrate cognitive services into your particular solutions. Here's an example of, I guess, how a call center may integrate with a few of the cognitive services that I've demonstrated today. So what is I guess this high-level architect or conceptual architecture is describing is a customer contact center platform providing either in batch or in real time voice data from contact calls to an Azure blob account, a storage blob account in this particular case. The creation of a new file could trigger an Azure function, for example, to read the contents of that voice data that's been sent to that blob container. And that Azure function could use the REST APIs or the SDKs that I showed you a few examples of to convert that voice data from to text using the speech service here. And then once converted to text, analyzing the content of that text using the text analytics API, for example, for sentiment, or extracting key phrases from that text that's been converted from speech. That could then provide some sort of near real-time or immediate feedback to the call center operator, depending on how quickly that voice data is made available to a solution like this. But certainly all that textual information, as well as the analytics of the text content has been converted from that voice call and can be provided to a data warehouse or other data store that other machines could learn from, and or be Power BI reports could be connected to present up the relevant information to different people in your organisation. Hopefully that makes a little bit of sense. Just finally, before we get to Q&A, a few resources for you to take away. All of the cognitive services APIs that I've mentioned today are they're obviously well documented by Microsoft. It's quite a comprehensive set of APIs, of course. It's a very broad range, very rich in terms of features. Those features are obviously being added to over time. So I certainly encourage you to begin at a high level if you're new to cognitive services with the introductory documentation provided by Microsoft, and then drill into each of the individual services from there for more information. Pricing varies from free to not free. SLA, it's worth mentioning that for the free tier on which I've deployed my cognitive services APIs for today's session, don't have an SLA, so you do have to choose a non-free tier to take advantage of that SLA that's offered for cognitive services. Microsoft's provided as part of the Azure samples, GitHub repository, provided a number of quick starts for many of the cognitive services that we've talked about today. And like some of the demonstrations, the code examples I provided to you, many of those are console application based, so they really focus on how you integrate your application code with the cognitive services APIs. I've also provided the link here to the Intelligent Kiosk app that I demonstrated to you a little bit earlier, if you want to dive in a little bit deeper into the kinds of applications you can build over the cognitive services APIs. And if there's any training you would like to, self-paced training you would like to follow through on, then Microsoft Learn, if you just search for Azure Cognitive Services, has quite a range of topics that you can follow there, or courses you can follow there rather. So that's it. Just ticked over the hour. Open up for questions. Hopefully, just in summary, that's given you a good introduction to kind of what is available via Azure Cognitive Services, the kind of the types of experiences you can build into applications by integrating with those cognitive services, whether they be vision-based, speech-based, or text, language or decision-based, and also just how you maybe begin that integration from at a code level point of view, what you might want to consider when you're deploying cognitive services for the first time, in terms of your options of deploying them into the cloud or into your own premises using containers, how you secure them, and a little more information about how you get started. So thank you for your time and thank you for listening.
Thank you so much, Chris. What a wonderful session and your demos. The best part that we learned is that you really don't have to be a data scientist to actually use these services. So you get a lot of out of box, and Azure Cognitive Services does the heavy lifting for you. I'm conscious of the time. I think we are about 6-7 minutes away before we can call it off, but we have a few questions aligned for you. Mm-hmm. And I probably start with the question that probably got a bit of a likes as well. So the question for you is that, could cognitive services be used to detect credit card fraud, or is it more relevant to Azure Data Science VMs? So essentially, cognitive services can be used to detect the credit card fraud, or is it more like an ML or AI thing?
Yeah, in my experience, that's more of an ML thing, where there may well be pre-built models available models available to use for those. Yeah, one thing to clarify, I think, and I mentioned this earlier in the session, was that Azure Cognitive Services are models that have been built by Microsoft and are managed by them with the option to configure a few of them, but it's not as rich in terms of its configuration or its flexibility or its scope in versus machine learning and what Azure machine learning has to offer. So I think for credit card fraud, that's probably a little more aligned to the machine learning scenario and less so to the cognitive services one. Having said that, I mentioned one of the cognitive services earlier, anomalies detector, could be one of those services that you may want to, whoever might be asking this and liking this question, to read more about, because that it may well be that credit card or that transactional data is something you can detect anomalies in over time, in that time series data set, to maybe detect and even prevent fraud in future. So certainly direct you towards anomaly detector and metrics advisor for scenarios like that. If you're not ready to dive deeper into machine learning.
Thank you, Chris. Another question which probably people want to know more about is when to use Q&A Maker and when to use Lewis. What's the difference? Yeah,
so the scenarios in which, and they're very close related, so that's a good question. Lewis is a more general purpose language understanding service. So if you're building conversational applications, applications are kind of driven by dialogue, chatbots, for example, then Q&A Maker is good for scenarios where there's kind of questions and answers you expect users to ask, and answers you expect or predict that you can reply with. In my experience, Q&A Maker is a great way for an organization to get started with their first bot, their first chat bot, whether that's presented through, say, a Teams channel, for example, or elsewhere, because it's easy to manage content. There's really nothing that you have to train Azure Cognitive Services on. You upload the content like I demonstrated, whether it be just basic Q&A or links to FAQs that are managed elsewhere. It's a good way to get started with a chatbot. If you really want a more advanced scenario, I guess the canonical example for the use of Lewis is more of a business process-based bot, where you want to may start the question. The user may start with a general question about where to find something or how to get started with something. That could be served by Q&A Maker content. But later within that same dialogue, you may want to start to hand them off to another bot that's driven by Lewis. And Lewis, in that particular case, would be trained on, okay, in this particular domain, they may be asking about, we'll need some help with processing an expense claim, right? So it's more than just questions and answers. Lewis provides the service. It allows you to understand what the user is asking and matching that against a response, which could be an answer, it could be an action, it could be a prompt for more information, whatever the case may be. So Q&A Maker, again, they're closely related or similar services, but Q&A Maker is good for FAQs and knowledge like that. Lewis, I think, is much better aligned to, or you used in scenarios where you want to provide obviously a language or dialogue-based experience for your end users, and understand what they're asking, so the application knows how to respond and the action that the application needs to take. Obviously, that being implemented as code.
Thank you so much, Chris. I guess we can take one quick more question because we are almost there. We are about 2 minutes away. So last question, and quickly if you can wrap it up, and that is, it's around that. Which cognitive services would help in identifying the signature section in an email?
The signature section, is that right?
So yeah, the signature section in an email, which cognitive services would you recommend or we can use?
Yeah, a good one to consider for that is the one that we've used, not necessarily for email signatures, is form recognition. And it might sound a little bit weird, but form recognizer is I guess the cognitive service API that understands layout, or you can train it on layout, understands layout and structure and the table data in documents. Doesn't actually matter what those documents are, but it can, as I mentioned earlier, it has pre-built models for business cards and receipts, for example, but you can also train your own model, whatever that may be related to, a purchase order, an invoice, or an email response, for example. It's probably the place to get started with that. It's quite a good question. I guess it's similar in terms of scenario to the business card that's kind of provided as a pre-built model. So maybe that's a place to get started there as well.
Thank you very much, Chris. Can you please move on to the feedback? So Thank you, everyone. Thank you so much, Chris, for your time. please share your feedback with us, because this is very important for us to improve our session or actually get a bit of an idea what actually you guys want to see in our upcoming sessions. So thank you again, and the QR code, please go there and give us your feedback. And Chris, you move next slide. And yep, this is our LinkedIn page. Again, the recording will be available at the end of this week on this LinkedIn page. So please go and join us. And thank you very much until we see you next time.
Thanks all.